mostly vocabulary. We want to be able to identify a maximum and a minimum and where a function is increasing, decreasing, or constant. So example 1, you do need to copy down the graph, so I'm going to give you time to go ahead and draw the graph and write the directions. Identify the local maximum and minimum. State the interval over which the function is increasing, decreasing, or constant. Might have to label those points too. Okay. So first, it's important to be able to identify the maximum and minimum. And we call these local max and min. Local is a mathematical word. It means nearby. So we want to look at some points and think, hey, which one's the highest of all of them? All right. So where do you think you have a local maximum? Where might a local maximum be? Say again? Negative 5, 4. Yeah, right here. This is what we would call a local maximum. It actually also happens to be the absolute maximum. It is the absolute highest point on our function, on our graph. And so negative 5, 4 would be the order pair for what is a maximum. Is there another maximum, or do we think that's it? What about this one? Do you think that's a maximum? So it's not an absolute maximum. This is definitely what we would call a local max. Local meaning for just the x values real close by. This is definitely the highest point compared to the x values really close by that output these y values. This is the highest one. All right, close by. Okay, so it is another maximum here at 5, 1. So we call that a local max because locally in a small little space, it's the highest point. Okay. What about the minimum? Are there some minimums? Where do you think? Uh, 3, negative 2? Yes. Right here is a minimum at 3, negative 2. And again, you can see that it's lower than all the other points close by. All right, in a small little space, that's definitely the lowest. Is there another one? What about the bottom of the well here? That is another little minimum value right there at -3, 1. Again, it's sort of at the bottom of the valley, so that's definitely a little local minimum. Okay. Now, I have a question for you. What about this point? It's higher than all of these on the left, but could we call it a maximum? This one we cannot call a maximum, and the reason is because there's all these points in between these two values, which maybe seem like maximums. There's a billion points in between here to make up this function, but can I say that one is higher than the other? No, because they're all at the same level. All right, so we can't say one is higher than the other since they're sort of all at the same place. Okay. All right. So if you can identify some maximums and minimums, that's really good. We also want to be able to identify where a function is increasing, decreasing, or constant. So constant, I like to do in this light blue color. And the important part here is that we want to know the x interval. The interval on the x-axis. That is the thing that we care most about because our x variable is our independent variable. The y value is the output because of whatever you plug in for x. It's going to give you the output for y. So the y value depends on what you plug in for x. So when we do intervals, we really care about the interval on the x-axis. So what are the x values? So the first one I like to talk about is constant. What do you think it means for a function to be constant? Where it what? It repeats itself. It repeats its y value. That's exactly correct. Well, where does the y value stay the same? What do you think constant means? If you were just to describe it. Flat. Right here. This section is where our function is constant. All right? It's not going up and it's not going down. It's totally the same. Constant, unchanging. Okay? And so what we want to know is what x values does that happen? So between what x values is that? Where does it begin? Yeah, right here at -2. And then it goes all the way to 1. And you'll notice that I'm coloring in the x-axis. I think that's really useful. You can do it or not. And so what I'm going to say is for x values greater than -2 and less than 1. This is the interval. X values between -2 and 1. It's really important when we're using this inequality notation that the smaller number is on the left and the bigger number is on the right. Okay, and we have all the x values in between -2 and 1. All right, that's the constant section. What do you think this little section of graph is? Is that increasing or decreasing? Decreasing, yeah, so I like to write that in. Decreasing means going downhill from left to right. Is there another decreasing section? Yes, there is. Going downhill from left to right. So there are 2 decreasing sections. And again, we want to figure out what x values does that happen for. So let's start here on this left section. Where does this decreasing portion begin at? Yeah, the x value is here at -5. And then where does it end at? -3. It ends at that minimum right there. So we want this section decreasing for x values greater than -5 and less than -3. or x values between -5 and 3. All right, we have another section that's also decreasing. So what x values does that happen for? Here is where it starts. What x value does it start at? 1. And it goes downhill all the way to here where it reaches its minimum. What x value does that happen at? 3. So for all the x values from 1 to 3. So x is greater than 1 and less than 3, or x values between 1 and 3. That whole little section is decreasing, going downhill. All right, so if decreasing is going downhill, what's increasing? Going uphill from left to right. So we have this little section right here that's going uphill, increasing. And from a minimum to maximum, again, this is another section that's increasing, going uphill from left to right. Okay. So over what x values? What about this first one? What x values? And -3 and -2. Yeah, between -3 and -2. You see how I'm sort of filling in my graph, my x-axis. I like doing that just because I know I got everything if I fill in all the spaces. So it starts here when x is -3 and it finishes right here when x is 2. So between -3 and -2. There's another increasing section. Where else does it increase from? 3 to 5. Very good. X is greater than 3 and less than 5. So starting here at 3 and going over here to 5. Okay, questions on that? Just vocabulary. Alrighty. All right, let's try one more. Go ahead again, copy down this graph. This graph has arrows. The other one had endpoints. Okay. Again, if you're finished, go ahead and label all your maximums and minimums. Do you think every graph is going to have all the different parts, all 5 max, min, increase, decrease, and constant? That's a big negatory. So not every graph has everything. So if you don't see something, you just put none. Okay. Maximum. Where's the maximum? 2, 2. Right there. Good. 2, 2. Ordered pair 2, 2. Definitely the highest point compared to those close by. It's at the top of the hill. It's a maximum. What about a minimum? -3. -3 is the minimum. Again, it's at the bottom of the hill, the valley, the lowest point. That's where all the water is going to collect. Minimum. All right. So, constant. We got a constant section. Constant. Where it's nice and flat. So, the question is, what x values does that constant section happen for? Good. -2 to 1 on the x-axis. Everything in between -2 and 1. So x values greater than -2 and less than 1. Or we can say x between -2 and 1. That's the only constant section. What about increasing? Where is the increasing section or sections? -3, yeah, right here. We got a little increasing section in the graph where we're going uphill from left to right. And that's starting here at -3 and going to -2. Good. So -3 is less than x is less than -2. Where else do we have an increasing section? 1 to 2, yeah, increasing here. Starting here and ending way up here. That's at 1 to 2. 1 is less than x is less than 2. All right, decreasing. Going downhill from left to right. So a lot of people, when they look at an arrow like this and they think it's pointing that direction, so they read that as going uphill. But it's not going uphill. It's decreasing because we want to start here on the left side and then move, and you can see that it's actually decreasing from left to right. And both of these are going downhill starting from the left, okay? So we want to talk about what this arrow means. What does that arrow tell us? It's going up vertically, but it's also going forever to the left, isn't it? So for what x values is our function decreasing? This one doesn't stop somewhere. But all these x values forever to the left of -3 are decreasing. So we could say for x values less than -3 forever, all the way to negative infinity, those x values produce decreasing y values. All right. And over here we have another decreasing section starting here at 2, and it goes forever to the right because, again, this arrow goes downhill, but it's going out as well. So for all these x values forever and ever and ever. For x values greater than 2. You could also say 2 is less than x. X value is bigger than 2, however you want to write that. Be careful. See how the big side is next to the x? That means x value is bigger than 2. X value is bigger than 2. So be careful. All right. Those are the 5 vocabulary words that you have to know today. We are also, on the back side of the worksheet you're getting is the same thing we did on Friday. On Friday, you were sketching graphs. You had to find the leading term, LT, leading term. And it had multiplicity. What was multiplicity 1? What did the graph do? Pass straight through. What was multiplicity 2? A bounce. Very good. What was multiplicity 3? A slide to the right. Okay? So that's all the things that we did on Friday. You're going to remember those. Okay?